Okay. Assalamualaikum to Sir Kamarul Zaman and everyone that will be watching our project demonstration. Today, we are thrilled to present our project for the automated fare collection system technology, which has recently evolved to include a comprehensive peer-to-peer carpool platform for university students. Okay, my name is Amir Rizwan, and I am joined by my partner, which is Hafiz and also Shazwan. Okay, let's start with the core problem. Traditionally, school and university transportation in Malaysia relies heavily on manual cash payment. This causes a lot of problems. Students losing their pocket money, delays while boarding the bus, and a huge administrative headache for operators who have to track who has paid and who hasn't. Furthermore, parents and students lack real-time visibility. Parents always worry about whether their child has safely boarded the bus, and university students struggle to find reliable, affordable transport back to their hometown. To solve this, we built a fully integrated cashless application. Originally, our system focused solely on automating school bus fare using NFC smart card. However, as we developed the app, we realized that university students face a huge transportation gap. So we expanded our scope. Our app now serves as a dual-purpose platform. First, it manages school bus fleets with NFC-based fare deduction and parent tracking. Second, it acts as a Grab Hitch-style carpool system where students and the public can offer or join rides, split fare, and pay entirely through our built-in e-wallet. Next, I will pass the presentation to Hafiz, who will explain our system architecture and the different user role in our application.
Okay, thank you, Amir. So to build a system that is both scalable and real-time, we developed this application using Flutter for our front end, allowing us to deploy to both Android and iOS smoothly. For our backend, we rely entirely on Firebase. We use Firebase authentication for secure sign-ins and Cloud Firestore as our NoSQL database. Firestore is crucial because this allows us to stream listeners, meaning anytime a wallet balance changes or a couple seat is booked, the UI updates instantly across all devices without needing to refresh. Because our platform connects multiple stakeholders, we engineer a complex role-based access control system. When you open the app, you will see our main role selection screen. We have 5 distinct roles. The operator, so we can sign into the operator first. So this is the admin portal. Operators can manage bus fleets, register students, link NFC cards IDs to student profile, and broadcast real-time announcements. Okay, next we will go to the driver. Drivers can be bus drivers or carpool hosts. So they have a scanner interface and that allows them to tap students into the bus. Okay, so this is the example for the driver interface. Validate and the trip log page. Okay, next we go to the parent. Parents can link their child's account to the app. So first we log in. So this is the parents dashboard. From the dashboard, they can monitor their child's wallet account, balance, top up funds via simulated payment gateways, and see exact timestamps of when their child tapped in or out of a bus. Okay, next we'll go to the student. Okay, so for the student, we give the account students their own independent accounts. So students can view their own NFC card details, check their wallet balance, and most importantly, access the carpool booking system. So finally, is for the guests. We realized that not everyone wants to create a full account just to look for a ride home. So we implemented an anonymous login feature. Guests can enter the app instantly to browse available rides on the feed, though they must register to actually book a seat. By separating these rules, we ensure that the UI is perfectly tailored to what the user needs. I will now pass the presentation to Shazwan, who will dive into a live demonstration of our core features.
Okay, thank you, Hafiz. And so I'm gonna explain the app actually work in real life. So first I'm gonna log in into the student account. Okay, firstly let's look at the NFC collection. Imagine a student boarding a bus. The driver uses their app to scan the student NFC card. In our code, we handle this using atomic file store transaction. This means the moment the card is scanned, three things happen simultaneously. So the file is deducted for the student wallet, and then a transaction receipt is generated. Then the student status is updated to on bus. If the student doesn't have enough balance, so the transaction fails entirely. It will preventing any database error or negative balances. Now let's transition to our most exciting feature, the P2P carpool system. Let's say a student want to travel from campus back to Malacca for the weekend. They log in into the student dashboard and open the book right there. Here we integrated opposite map to our location search dedicate instead of typing a random string of text. The student searches for a real validated location. Once they are select their origin and destination, our app calculate the total distance in kilometer. So I'm gonna demonstrate the flow. Okay. Mm, So this one is um the origin location and the destination and the estimated distance, the number of passengers. So these are the fare estimation. This fare, distance fare, and then divided by, so the total cost is RM2.56. So I'm gonna confirm the payment. So and that firstly I'm gonna explain that we pay a automatic fare calculation algorithm. It take a base fare at a rate per kilometer and divide the total cost by the number of passengers sharing the ride. The student agree to the estimated fare. The press confirm payment. That they check their digital wallet, deduct the specific amount. So the deducted is RM3.50, and the remaining balance is 28.90. Then the student can check the transaction history here. So, but what if a student has their own car? They can easily switch to the offer a right screen. So they set their departure time, origin, destination, and how many empty seats they have in their car. Was published. Published. This will appear on the live global feed. Other student or even public guests can scroll this feed. As people join the ride, the available seat count decreases in real time across all user screens. So I'm gonna demo a little bit. Time and seat. Okay. And then this create a self-sustaining ecosystem where students can save money, reduce their carbon footprint, and travel safely with very fast peers. So for the next part, I'm gonna pass to my partner, Amir. Thank you.
All right. Thank you, Shazwan, for that detailed walkthrough of our system and also Hafiz. To wrap up, our AFC couple platform successfully bridges two major gaps. Firstly, it digitized the messy, cash-based school transport system, and it provides a modern Grab Hitch style ride-sharing alternative for university students and the public. By combining secure Firebase backend architecture, atomic wallet transaction, and real-time location searches, we have built a robust MVP, minimum viable product that is ready for the real world. Looking toward the future, there are several enhancements we plan to implement to make this system even better. Firstly is hardware integration. We plan to integrate physical NFC card readers using Raspberry Pi or Arduino for the buses, rather than relying solely on the driver's smartphone. Secondly is real payment gateways. Currently, our top-ups are simulated. We plan to integrate Stripe or FPX so parent and student can top up via online banking or credit card. And lastly is live GPS tracking. We want to integrate Google Maps APIs to allow parents to track the exact GPS coordinate of the buses as it moves along its route. Thank you for your time and attention today. We believe ASC Kapul has the potential to revolutionize student transport in Malaysia. Thank you, everyone.